Um, Statistics student, this video is for chapter 11.3, still on tests, continuing tests of independence. We're going to do another test called test of homogeneity. Test of homogeneity is very much similar to test of independence in terms of the method, in terms of how you do this, but it's just a different name and a different purpose. So if you have sample data summarized in a contingency table from different population showing different a proportion of a category or different count of a different category, so we can also use chi-square test to determine whether these population have the same proportion of some characteristic being considered. And this is called test of homogeneity. That means we're testing if their proportion of a category are all the same uh, uh, in the classification of a particular categorical variable. So the chi-square test is the test of claim that different populations have the same proportion of some characteristics. For example, we look at how 3 different population of workers choose to commute to work, the choice of transportation. Okay, so it is here. So if for 23 sales people that we interview, 20 choose private, 1 choose public, 2 choose share, whereas for 23 technology profession, 10 choose use private car, 3 use public, 8 use share car, and 2 use bike, etc., etc. So the horizontal rows, sometimes it's column, with the 3 population, and the vertical columns are the choice of transportation to work. So the homogeneity test will be testing between these 3 populations. Their choices are the same. That means the people's choice of transportation is not affected. Well, actually, I should not say that. There is nothing to do with affection, whether it affects it. Is that for this population, their choices of the percentage of people choose certain transportation choices have the same percentage proportion. So the difference between this and the test of independence is how samples are collected. In test of independence, usually you collect from one big population and then you classify them 2 ways. In a test of homogeneity, you actually have 3 different populations and you know how many you want to collect for that sample. So you would know these 23 are all from sales, and then you look at how they classify in the choices of choices of transportation. So see, the only difference is how samples are collected, the name of the test, and how H0 and HA are written. So the other difference is when you write the null hypothesis and also the alternative hypothesis, you do not write independence. You just say proportion of transportation choice are the same among the 3 population. Okay, so let's just do this. Oh, I think this one I need to cross out. I'm doing example 1. Okay, so test the claim that choice of transportation are different among the 3 profession of workers. I think there's a big difference here in technology. They like 8 people out of 23 use share transportation like van pool, or I think maybe this the company provided bus also those shared transportation. So see how you would write it. You would write X0 is proportion of transportation choices are the same. Alternative is at least one of the choices are different. So maybe just the share one is different or the others are the same. The alternative is that is at least one. So again, it is a right-tail test for chi-square because again, you use expected count to compare with observed count to see if you have a big chi-square value. So what we do is we input this table into Statistic. Okay, so I have that table here. So do I have it? Yeah, I have it here. I don't input the total in. It's just the copy. And then I need to do status. These are what we did last time. So we erase them and also erase the table. Clear all this. And now we do Control V. Oops, Control C. Yeah, try again. Copy again. And then I do Control V. Okay, so the way to analyze them would be contingency table. So that's the reason why they don't call it a test of independence. 3 of them, right? Then we say, is it 0.05? I don't think it matter, but we should do that. Yeah. I didn't say, so maybe I should just test the claim. So I would say I add it back to 0.05. Use the default. So when we do the this test, we do this and then you evaluate. So the degree of freedom is 4. Test statistic chi-square, the observed minus difference is 14.17, and then p-value is 0.0068. Okay, so I record it here. 1, 2, 3, 4. Right? Did I do 1, 2, 3, 4? Oh my gosh, I forgot. I should redo it again. That's wrong. That's why the degree of freedom is 6, because it should be 3 times. Oh yeah, 1, 2, 3, 4. 4 minus 1 is 3. 1, 2, 3. 3 minus 1 is 2. So 2 times 3 is 6. Yeah, degree of freedom is 6. So remember, you have to click all the columns. Sometimes you don't see them. And then chi-square is 20.13. Yes, we evaluate again. 20.13 degree of freedom and 0.0026. So again, 0.0026 is less than 0.05. We reject 0. Conclude that it's different. Okay, if you reject 0, 0 say that they are the same. So if you rejected it, you conclude that at least one of the choice of the population is different. At least one. So there is sufficient evidence to support the claim that the choice of transportation is different among the 3 population professions. So then the last thing is to do expected count. So I have all the total, row total, and column total here. So I just need to do the least expected count. So 6 is the least here, and they're all the same. So 23. So I'll do row total, column total over grand total. The grand total is adding all these together. So this is 6 times 23 over 69 equal to 2, and that's less than 5. So although we have the conclusion that they are different, but because the expected count is not at least 5, so the requirement for chi-square test is satisfied. You can use the result for reference, but you should not publish it. The result may not be reliable because chi-square require that each proportions are normally distributed. And if your number of success or number of failures are not at least 5, they're not. So you should collect more samples. So this, if you have 0 or 1 in these, it is very highly likely that the least expect count cannot be at least 5. The last example is the use of this to in the court. This is actually a real question that has been or a real story that has been posted on in New York. So there is a firefighter exam, I think, for firefighter to be promoted to supervisor or something. And it turns out that most of the people that pass are white candidates, or they have a higher percentage of passing compared to minority candidates. So a lawyer actually bring these results onto the court, and actually they win the discriminatory uh, complaint, saying that the test is discriminatory because it makes it so that the minority candidates actually fail more. So if you look at this, The minority candidates had 30-something people. White candidate also had around 30, but the failure rate is so much higher, right? 26 fail out of how many? Out of 33 that's take the exam. So how do you persuade people that this is not because of sampling distribution? So you would do X0 white and minority candidate have same chance of passing. Say X0 is always data, there's no difference, the race does not affect it. It should be, right? And then the alternative hypothesis would be white and minority candidates do not have the same chance of passing. So alternative is always expecting a chi-square value, and then our claim is HA. So we input the tables and then see what we can do. So the next one is this one. Okay, so I'm gonna input this, copy, clear all these, clear this also, put it here, Control V. So we have 2 columns, 2 rows. Do we use 0.05? Let's see. I don't remember if we say we use 0.01 or 0.05. We use 0.05 in this case. Okay, so and then I have evaluate. Degree of freedom is 1 because we only have 2 rows and 2 columns. And then test statistic is 6.28. This is the expected and the difference of expected and observed count. And then p-value is 0.0122. 0.0122. So it is really low, right? So come back here, 0.0122 is less than 0.05, so we reject 0. Conclude that the two populations have different chance of passing. And then the final conclusion about the claim is because we have a rare event, there is sufficient evidence to what? To what was our claim? The claim said that they're discriminatory. So to support the claim that white and minority candidates do not have the same chance of passing, so the exam is, discriminatory. And then let's check the requirement of at least 5 for expected count. So we look at the total. So this is the smallest row total. This is the smallest. Oh yeah, I should not use 33. I should do 29, right? So 22 times 29 over 62. So you just calculate the minimum expected count times 29 divided by 62. So it should be 10.3. It's still greater than 5. This is 10.3. I'll change the note. So the test requirement is satisfied. And you would say because they are different, so you would say this shows that the test is discriminatory. Okay, so that's the end of chapter 11.